Here's a brief video on the physiology of the bladder. So the bladder is a small pear-shaped organ situated at the lower part of your abdomen. It can hold about 500 to 600 mils of fluid, and its main function is storage of the urine and then the emptying of that urine. It fills through ureters that come down the kidney, and as it fills, then there is a reflex action called the micturition reflex that signals then to the brain that there's the desire to urinate, and then urination is a coordination of a reflex response and somatic control that coordinates contraction of the detrusor muscle and relaxation of the external sphincter that results in emptying the bladder. And when the bladder empties, it typically empties everything to about 5 to 10 mils. So the anatomy of the bladder is shown here. You can see it's a pear-shaped organ, and this sort of external layer of it is mainly comprised of the detrusor muscle. That function is defined in being able to contract over a wide range of stretch. And then away from the bladder body, you have this sort of trigona area that has an internal sphincter, followed by this urogenital diaphragm that has an external sphincter, and then past that you have the urethra. Notice that urethra is much longer in the males, and you have this prostrate gland that sits in between the internal and external sphincters. Looking at the bladder body inset a bit closer, we see that the detrusor muscle has three layers of smooth muscle, and in between these you have gap junctions that facilitate the flow of signals so that the bladder squeezes downwards and ejects the fluid in a downward fashion. You have as well these folds are called rugae, and then below this is the bladder neck, where you have the inlet from the ureter at the top, then the smooth mucosal layer that ends in this ureteral sphincter that's kind of kept closed mainly by its elastic properties, and then this external sphincter that is under somatic control. So the bladder is innervated by the central nervous system, and there are three sort of innervations. You have the sympathetic, which generally results in inhibiting the contractile responses of the bladder, and this is through the hypogastric lobes that come out through the L2, and these innervate both the bladder body and the neck. In the body, they're beta adrenergic receptors, and in the neck, they're alpha adrenergic. The beta adrenergic result in relaxation of the bladder body, and the alpha adrenergics then contract the neck to prevent urine flow. The parasympathetics are then what contracts the bladder body, and this is through M3 muscarinic receptors. And then at the bottom we have the pudendal nerves that have nicotinic receptors in this external sphincter, and that is under somatic control. When the bladder fills, you get a change in pressure. This affects stretch activated ion channels, and this sends a signal to the central nervous system that then tells the bladder to contract in a reflex action. And so if we look at this graph, we have intravascular pressure followed by the volume, and as the bladder fills, the pressure increases to the point where these stretch activated ion channels sends a signal to the central nervous system and tells the bladder to contract. And then this is what the micturition reflex is. As the bladder stretches, you get a reflex contraction, and the more pressure in the bladder, the more it fills, the more you get these micturition contractions and the urge to urinate. So the micturition reflex is a cycle of filling followed by these contractions that are sent from the central nervous system, and if the bladder isn't evacuated, then you'll have a refractory period where these contractions kind of fall away until the bladder fills some more and the micturition reflex starts up again. It's an autonomic spinal cord reflex. As I mentioned, you need signals from the spinal cord to cause the bladder to contract, and these reflex contractions are controlled by the micturition center and by the sympathetic nerves that allow you to decide where you want to empty the bladder. And so this sort of shows you how the bladder is regulated by the central nervous system and by the micturition center. So we have the bladder here, and we have the pelvic nerve, and here we have the hypogastric nerve, and then the micturition center that combines down here, and then the pudendal nerve here. During the micturition reflex, signals are sent to the sacral cord and then back that tell it to contract. The hypogastric nerve contracts the bladder outlet and inhibits the detrusor, and so that's the way that the body prevents involuntary incontinence. But then the micturition center is the voluntary control, and this inhibits the sympathetic and the sphincter reflexes and allows then the bladder to contract, and then the pudendal nerve, which is under somatic control, allows the relaxation of the external sphincter, which then allows you to urinate. So the bladder, particularly in later stages of life or after some insults, can become dysfunctional. The urethra can become blocked by an enlarged prostate, and this obviously results in increasing pressures in the bladder. And as the bladder works against this higher pressure over a chronic period of time, the bladder undergoes hypertrophy. This hypertrophy, though, is dysfunctional because there's poor calcium handling, resulting in a reduced contractile pressure, and so this has a sort of a vicious cycle of getting worse and worse until it's corrected. You have other conditions like atonic bladder during syphilis or some spinal injuries where the central nervous reflex to the bladder is cut, and so the bladder just fills and overflows, and there's no reflex, there's no contraction, it will just be a constant rate of urination. The automatic bladder is when the spinal cord is damaged above the sacral region, so the CNS does tell the bladder to contract, but there's no somatic control, and so as soon as the micturition reflex begins, then the bladder is evacuated. And then you can also have an inhibited neurogenic bladder where the hypogastric nerve is cut, and this is characterized by the overwhelming urge to urinate and constant incontinence. And then you can have a weak external sphincter, such as in times during pregnancy where the pressure on the bladder is so much and so constant that it often just overcomes the external sphincter pressure, and this is known then as stress incontinence. Just to sort of clarify some of those nervous issues that the bladder can have, sometimes when the pelvic nerve and the pudendal nerve is cut, then there's no reflexes from the sacral cord and there's no tension on the external sphincter, so as it fills, it just evacuates, constantly giving rise to urine. The automatic bladder then is when there's no regulation from the higher centers, the hypogastric nerve doesn't inhibit it, and the micturition center doesn't stimulate it, and so as soon as the micturition reflex starts, the bladder evacuates. And then finally, with an inhibited neurogenic bladder, here you have the hypogastric nerve that's severed, and so you have no inhibitory responses on the bladder, and this results in the constant need to urinate because the micturition reflex is just that much stronger constantly. And then stress incontinence results from factors that either make it harder for the sphincter to maintain pressure, or that the pressure in the abdomen constantly overrides the external sphincter.